Section 2, Module 10, DC Coupled and Hybrid System Pitfalls, Avoiding False Production Readings. Hybrid solar plus battery systems are increasingly common, and they introduce a measurement challenge that doesn't exist in standard solar-only systems. This module explains exactly what can go wrong and how to avoid it. Here's the core issue. On hybrid systems, the inverter output equals PV production plus battery activity combined. This creates two false reading scenarios. The first is a false low. When the battery is charging, solar energy flows into the battery first, so less energy reaches the AC output. You might measure 4 to 6 amps on a system that should be producing 10 to 12. Field indicators include strong irradiance but low amp readings and a battery that's likely still charging. The second is a false high. When the battery is discharging to assist house loads, it boosts the AC amp reading beyond what solar alone is producing. You might measure 16 to 18 amps when the system should only produce 10 to 12. Field indicators include a large appliance running or an amp reading that jumps suddenly. The AC amps at the solar breaker are only reliable when the battery is full or idle, meaning battery power flow is approximately 0. Let's look at a concrete example. Take a 3 kilowatt system at 900 watts per square meter irradiance. Expected output is roughly 10 to 12 amps. In a normal reading with the battery full and idle, you'd measure around 10 to 12 amps. That's accurate. In a false low scenario with the battery charging, you might only measure 4 to 6 amps. The solar energy is being diverted to charge the battery. In a false high scenario with the oven running and the battery discharging to assist, you might measure 16 to 18 amps. The battery is boosting the output beyond what solar alone is producing. The most accurate measurement window on a hybrid system is when the battery is full or idle, typically midday to late afternoon, when the home load is relatively stable and you see no charge or discharge arrows on the system display. For verification, prioritize the inverter production display, which shows PV production directly. The system monitoring app often separates PV from battery flow. Use the battery state indicator to confirm the battery is idle before clamping. Only use the breaker clamp reading if battery flow is approximately 0. The inspector workflow for a hybrid system is: first, confirm it's a hybrid. Second, check the battery state. Third, if the battery is idle, proceed with clamp measurement. Fourth, if the battery is active, use the inverter display or monitoring app instead. Fifth, document which method you used in your report. Here are the key takeaways. On hybrid systems, inverter output equals PV plus battery, not solar alone. A false low happens when the battery is charging. Morning readings may show artificially low production. A false high happens when the battery is discharging to assist large loads. The best measurement window is when the battery is idle, typically midday when it's full. When in doubt, use the System Readout. Inverter displays and monitoring apps separate PV from battery flow. And always document your measurement method in the report. Knowing these pitfalls protects you from drawing false conclusions and ensures your reports reflect the actual solar system performance.